Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to calculate the input impedances of all of these circuits. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell so whenever I upload a new video you'll be aware of it. Let's jump into it. Before I'm going to calculate the input resistance of these different amplifiers, notice that I created a video for how to calculate the different impedances from the base and the emitter of bipolar junction transistor. Here is the link for this video. You had, if you're not familiar, you can look at this video and then come back to this one, because this is some sort of example for that video. Okay, now let's look at the first two circuits. This is the first one, and also notice that this is from the Razavi's book, chapter 5. Okay, I write it down in the description, the reference for this video. Okay, now let's look at this amplifier, how we can calculate the Rin resistance. The classic way is to just place the small signal of this bipolar junction transistor, place VA test and the I test, and calculate the fraction of VAT divided by IAT. But I'm just looking at the circuit and then calculate the Rin without using KVL and KCL, just seeing the resistance from different nodes. So just start at the end. Here for this Q1, what is the resistance seen through the base of this BJT? It's actually R pi with a subscription of 1. So here I'm going to redraw the circuit again to calculate Rin. Here we have R1, R2, and this is R pi 1 from the BJT transistor. Now if you look at it, it's really simple. These two are parallel, and the equivalent resistance are series with R1. So the whole Rin for this one here equals to R1 plus R2 parallel with R pi 1. Okay, this is the whole resistance. And how about this one, Rin? Again, you had to simplify the circuit by calculating what is the resistance through this emitter of Q1. When I look at the emitter, I had to divide the resistance from the base by the fraction of 1 plus beta. So here this is R pi 1 divided by 1 plus beta, or as the Razavi's book said, that it's equal to 1 divided by GM1. So I'm going to again redraw the circuit. Here this is R1, and here this is 1 divided by GM1 for Q1. Okay, now what is the Rin for this circuit? As you can see, this R1 and this 1 divided by GM1 are parallel, because this is the common node and you can connect the ground together. Okay, so these two are parallel. Rin equals to R1 parallel with 1 divided by GM1. How about this one, Rin? Let me just again redraw the circuit. Here we have Q1, and VCC is connected to the ground for the small signal model. How about Q2? Q2 is actually diode connected device. When we connect the base and collector of the BJT together, you have a diode connected device, and I already posted a video about how to calculate the connected device, the diode connected device, and this is the thing that you can replace a resistance against that, because this is just had two nodes, okay, and its resistance equal to 1 divided by GM2. And now I'm going to calculate R in. So in order to calculate R in, what is the base resistance for Q1? Is actually R pi 1. And how about 1 divided by GM2? 1 divided by GM2 is placing at the emitter, so it is not the same when we look at it from the base. You had to multiply 1 divided by GM2 by 1 plus beta. This is what we discussed already on that video that I discussed at the beginning of this video, okay, about how we can see, and I prove it on that video. Okay, now look at this circuit. How about this one? Again, I'm going to redraw a circuit, a simplified model of this circuit. This is Q1, this is ground, and this is Q2. How about Q2? What is the resistance seen from here? This is just R pi 2. There is no resistance on the emitter to multiply by 1 plus beta, and sorry, this is beta 1, okay, this is beta 1. So here I'm going to replace it by just R pi 2, and this is ground. And now I can calculate R in by the same strategy I calculated in here. So here R in equals to, again, R pi 1 plus R pi 2 times 1 plus beta 1. This is a really great strategy. I told you already, you had to keep that in your mind, this formula about how we can see a resistance from the base when we look at through the emitter. Okay, I hope you like this video. That's all there is for this video. If you like it, please give me a thumbs up and share this video with your friend. Thanks for watching.